Hello there! How are you? Now, let's consider these two functions. We have f of x is equal to x squared minus 4 and g of x being 2x minus 4. Let us solve for the product of these two functions as well as the quotient. So let's start with f g of x. If you have an expression like this means you're solving for the product. And whenever you are multiplying functions, especially for our given, since both of them are binomial expressions, enclose both of them in a parenthesis. So you will have here for f of x, x squared minus 4, and for g of x, which is 2x minus 4. Please do not forget to enclose them in a parenthesis so that it means you are multiplying the entire function to the another entire function. Here, we have binomial times binomial, so we are going to use here the FOIL method. Starting with the first, x squared times 2x, you have 2x cubed. Inner terms, negative 4 times 2x minus 8x. Followed with outer terms, x squared times negative 4, you have minus 4x squared. And finally, negative 4 times negative 4, that's positive 16. For the final form of the result or the product of the two functions, you might want to rearrange them into a decreasing order of exponent of x. So you will have 2x cubed to be followed with minus 4x squared, then minus 8x, and then plus 16. So this is now the result for the product of the two functions. By the way, if you're also asked about g of f of x, you will end up with the same result. This is because g and f are just multiplied with each other, and multiplication is commutative. So it doesn't matter which function is written first in the process of multiplication, you will end up with the same result. But the same thing cannot be said for the quotient. Just like first, you have f over g of x. The result of this will be different when we are asked later. We were going to show a sample later when it's g over f of x. Let's start with this. F over g of x, where the value of the entire g of x is not equal to 0. So as our entire result will not be undefined. So f would be our numerator, x squared minus 4. And our denominator is the entire g of x, 2x minus 4. This is now a rational expression where, again, the result of our denominator, 2x minus 4, could not be equal to 0. By the way, do not be confused as to canceling this 2, 4, 0 or 2, negative 4. Because these two terms are separated with their corresponding pair in both numerators and denominators by an operation of subtraction. The cancellation law can only be done when terms are separated by multiplication, because the complete name of cancellation law is the cancellation law for multiplication. But this is not yet our final answer, because if there is something that we can do to simplify it further, we need to do it. Just like 2/4, 3/6, 5/10. They're already okay fractions, but their simpler form, or the simplest form of those three fractions, are 1/2. And we need to express all of our answers in their simplest form. How do we write the result of this into its simplest form? We can use here factoring. When we factor our numerator is a difference of two squares. It's called a difference of two squares because the two terms are separated by subtraction. And both terms are perfect square expressions. X squared is the perfect square of x. 4 is a perfect square of 2. With that, we are now assured of having two binomial expressions as the factors. By the way, why are we factoring? We are doing factoring here because probably later there might be some terms or coefficients or expressions that can be cancelled. So let's try to factor our numerator. Again, same first term, same second term. They only differ with the operation separating them. Square root of x squared is x. X here as well. Square root of 4 is 2, and you have 2 here as well. This is now the complete factor of x squared minus 4. Let's have it all over our denominator. The denominator cannot be factored using difference of two squares, but we can use here the common monomial factoring. We can factor its greatest common factor of 2, leaving 2x becomes x, and minus 4 becomes minus 2. Now that we have these two factors, notice they are called factors because now both terms on our numerator and denominator are separated by multiplication. We can now use the cancellation law for multiplication for x minus 2 because it's the common binomial expression found in both. In short, our final answer for f over g of x is x plus 2 all over 2. Again, we cannot cancel this because the 2 on our numerator is part of a binomial expression. As mentioned earlier, we cannot have the same result if we have this next expression, g over f of x. Let's try to show. So g of x is our numerator now, 2x minus 4 all over x squared minus 4 being the denominator, where gx squared minus 4, our f of x, is not equal to 0. So we use the same factors earlier, 2 times x minus 2 all over x plus 2 times x minus 2. We can cancel this, leaving the result to be 2 over x plus 2. These two results are not the same. Just like 3/4 and 4/3, they are not of the same value. So again, we don't have commutativity for division, but for multiplication, we have commutativity. These are the results for the product and the quotients of these two given functions. That's all for today. You're dismissed. And please do not forget to subscribe now.